you want to talk about? When I was running off the quiz this morning, or the test this morning, I was getting kind of sad because it's the last one. No. And I know, and that means our time together is almost over.
No. Why does it be over?
Well,
Hey,
for
Jade,
those of you that haven't spent summer
can you
school
sharpen
with
this?
me.
Oh, Jade didn't switch over, she was just scored.
Are we calling people out?
But, boys.
Late.
You have a pass?
Yep.
Reyes, have a pass?
That's crazy because I was in the same class and I got That's crazy? No. That's crazy.
You didn't do your run through.
Okay,
You
but
guys so bad.
I just do, I don't think I've ever told you this. I ask every year, and sometimes I get it, and sometimes I don't. I always want to have an academic class because, you know, I've got the CPs, and I've got the APs, and I just think academic is fun. So,
average.
I am grateful to have had this year with you.
Yes.
Wait, Mrs. Ford, in the email, did you say we get the formulas now?
Yeah.
Is that all of them?
Did you read the
read it?
email?
Read
I read it, I didn't know if you're
Oh.
talking about all of them or just 3 of them.
Why would you just
Why
give
would
us
we
a
all-
couple of the
Yeah, we're gonna
formulas?
get 1.5, like, come on.
Hairball.
Miss Ford.
Holy, bro.
All right, here we go.
Were we your favorite class?
Yes. Let's go.
Wait, all time or just
This year.
All time would be
I don't know,
all time.
that would be kind of a tough one.
We top 5?
Are we top of the head running? That's
Every
45,
year I
40?
just love my,
45 years.
okay. This was not on the review sheet, but I believe it's something we should remember. Hint, hint. Now, what does that symbol mean I'm supposed to be doing?
Finding the numbers.
Well, I need to add them. I'm going to be adding them. Now, what are the numbers that I'm adding? Remember, you start by plugging in 1, and that would be 4. And then you plug in 2, and that would be 7. And then you plug in 3, that would be 10. And you keep plugging until you get to plugging in 53. Is that 160?
Yes.
Yeah, my calculator to make sure.
59 plus 1.
Okay. Now, yeah. Now, those are the numbers. You are not going to have time to list them all out and add them up individually. That you're not going to have time to do that. You're going to have to use one of your formulas. Is this sequence arithmetic or geometric? Arithmetic. So the arithmetic formula, and I'm going to give you the formula, but I'm not going to tell you it's arithmetic. But we talked yesterday, the geometric formulas all have an R. If you're arithmetic, you're picking a formula that doesn't have an R. This is the only sum, adding, sum that doesn't have an R. Okay, how many terms are there? We went from 1 to 53. 53. The first one is 4, and the last one is 160. This is a really easy problem if you know what you're doing. So the sum is 4,346. All right? So these are, if you don't know what I just study, practice, some in the notes. Now another one was kind of on the review sheet, but not exactly, is, let's say we're gonna have a 5-card hand, and we wanna find the probability of exactly 2 queens.
So, 50 C.
What question question was the answer to.
I'm making this up. Okay, so I want the probability of exactly 2 queens. So it's a fraction, probability. The denominator is 52C5 because I'm choosing 5 cards out of 52, right? 52C5. Now the numerator is what I want. So I want 2 queens. How many queens are in the deck? 4. And I want 2 of them. However, there's more to the story.
You want 3 of any
3 of non-queens. 3 cards that aren't queens.
48.
48. C3, that's exactly right. So you can type that in on your calculator and get whatever the answer is. But I wanted to make sure you remember, if it's a 5-card hand, obviously there's 5 in the denominator, there have to be 5 in the numerator. So 2 from the queen, 3 from everything else to do that. Okay, then I jotted down this one. X minus 3 to the 7th, and I want the coefficient of the x to the 4th term. So, does everybody get that if we failed that out, there would be a term that would have an x to the 7th in it, and then there'd be a term that had an x to the 6th, an x to the 5th, x to the 4th. So there is a term out there that has an x to the 4th.
So you do C7.
And I need its coefficient. Okay? Now, I could use the 7th row of Pascal's triangle. Now I'm gonna write out some rows, but obviously I'm not writing out infinitely many rows. So you can either take what I started and build more if you need, or you can remember that the numbers in the 7th row of the triangle are these. Those are the numbers in the 7th row of the triangle. I'm giving you the triangle written out to a certain number of rows. Let's say I wrote it out to 5 rows. Then you could add the 6th and the 7th, if you wanted to, or you can remember that these are going to be the numbers in the 7th row. Now, we want the one that has x to the 4th. This one is going to have x to the 7th. This one is x to the 5th, x or 6th, 5th. So 7C4 is the one that's going to have x to the 4th. Right? So 7C4, and again, you can build the triangle. It's going to be 35, no matter what you do, you're gonna have 35. And it's gonna have an x to the 4th. And what else is it gonna have? A negative 3 to the 3rd. Remember, every term of the expansion is going to have an x and a negative 3. If it's to the 7th power, and we've already figured out the x is 4, then this one's gotta be 3. Now, what is negative 3 to the 3rd? Negative 27. So negative 27 times 35 is negative 945. So the coefficient on your x to the 4th would end up being negative 945. It's the 35 you got from the triangle times, in this case, negative 3 to the third. Okay?
Okay.
All right, so that's all I jotted down. Now, let's make sure, I starred a couple from the sheet that I wanted to make sure we did. So let's get these done before lunch, and then we'll do whatever you still have questions about. Look at number 17, problem 17.
Need a little bit. Grab it. I got you a little bit.
Hey, you don't trust out.
You're good.
All right, so what does problem 17 look like? Sue ate 32, 35, 38, and so on. So this is arithmetic,
That's a lot.
right? Now, I only have 2 arithmetic formulas. If you look at your 5 formulas, they all have R's, except this one, and the one you had in the board earlier, this one. Question 1 says, how many did she eat on the 90th day? So don't I want to find a sub 90?
Yeah.
So according to the formula, a sub 90 will be 32 plus 3 times 89. So she's gonna eat 299 candy kisses.
Jeez.
What,
I
dude?
know. I could probably do it, though I love candy kisses. All right.
There's like the chocolate kind of thing.
Was it Hershey Kisses?
No.
Oh, Hershey, the chocolate.
Yeah.
Nah,
I think it's like an
like the Valentine's Day ones where they put little.
How many-
I don't think it's like.
No, those are conversation hearts.
Yeah, those are.
How many had she eaten all together
I'm sure.
in 180 days?
Okay.
So that is this formula, right? Because what does all together mean? Add them up. Add them up. So this is how many she ate on the 90th day. But she ate some on the 89th day, and so on and so on and so on. We need to add all those up for 180 days. So we need to find the sum of 180 days.
Only some.
So 180 over 2 times 32. Uh-oh. What goes here?
No.
A sub 180. Don't I need to know how many she ate on the 180th day?
Yes.
I don't know that. So I'm gonna have to figure this out. So A sub 180 is 32 plus 3 times 179.
Yeah.
And that's 569, but it is not the answer to the question.
Good at.
That is just this part, right?
Yeah.
So now I need to add 32 to that and multiply it by 90. Oh my goodness. This might even be too many for me. 54,000.
That's a lot.
That's a lot.
That's a lot of chocolate. And 188.
All right, what
I
else?
love
did
chocolate.
start?
I can't eat all this shit.
It's too much. I love. You can't handle all that chocolate.
I can't.
Okay,
Like, I can get a good amount.
all right. Number 13. These are just a few I starred to make sure that we touch base on them. After lunch, we'll talk about whatever you want. It's math, I mean this, you gotta do this. Okay. There are 137 students in the gym. Here's the gym, there's 137 in there. All of them like basketball, volleyball, or both. So in other words, there's nobody out here. They all like one or the other. 82 like basketball and 77 like volleyball. how many like only volleyball?
Okay.
Okay. So remember, there's 137 kids. Hey, you 137, how many of you like basketball? 82 hands went up. Okay, put it in there. How many of you like volleyball? 77 hands went up. We have a problem, because there's only 137 kids in the room, and how many people voted?
22.
Well,
So it's there's 22 in the
159
middle.
voted,
Yeah.
which means 22
Like
voted
both.
twice.
And then you subtract 22 both of them.
You do
So
159
this
minus
would be
157.
60,
Yeah, 82
And
plus
then
60.
you could drink that.
and
You're
this
good
would be
though. I don't know what you're
55.
trying to say.
Hey,
Everybody follow all that?
8's not falling.
So the question is, how many like only volleyball?
55.
55. Now I'm gonna add a question to that.
Okay.
Suppose I reached into my box of people, here's my box, I reach in and grab one out. What would be the probability of getting one who likes both?
22 divided by 137.
22 out of 137, that's exactly right, 22 over 137. Okay, number 14.
Someone want to do it on the board? Someone want to do it on the board?
Now, you can do it on the board after lunch, okay? Here we go. Number 14 says, there's a 94% chance that we're gonna get to 75 tomorrow. When the temperature is at least 75, there's a 22% chance that we'll run a mile. If the temperature isn't, there's a 64% chance that you'll run a mile. Find the probability that you will run a mile. Does everybody feel like tree diagram?
Yeah, I'm
Yeah.
feeling it.
Because what's happening? We have the temperature and we have the running. So the first branch is going to be the temperature will reach 75, or will reach 75, and won't reach 75. All right, so my temperatures will be 75 or not be 75.
And then run them on.
And then I'm gonna run or not run. So if the temperature is at least 75, running is 22 and not running is 78. If it's not 75, running is 64 and not is 36. There's a 94% chance it'll get to 75. All right, so take a look at that setup. Does that make sense to you?
Yeah.
Tomorrow, you get to
Yeah.
do this by yourself. Okay, we got it? All right, now we want the total probability of running. So here's a run and here's a run. So we're gonna take 0.94 times 0.22,
Plus.
and we're gonna take 0.06 times 0.64, and we're gonna add them together. Because it's either running on a hot day or running on a not hot day. So what means that? You okay with that one? Everyone? Okay, so what I wanna make sure, do we get, when you read this question, the basketball volleyball question, did it feel like a Venn diagram to you? And then when you read this one, did it feel like a tree diagram to you? Because I won't be standing up here telling you this is how to set it up. You're gonna have to figure that out. All right, number 15.
Yeah.
Did you already do 15? Yes, we did
Yeah.
15.
Yeah, we did.
Number 8. You already do 8?
We did. No, we didn't. No, we
No,
didn't.
we didn't.
We did 8. So let's do number 8.
14.
All right, find the third term.
10C10.
Now, thank goodness I'm not doing the whole expansion, because this thing would be big. I only want the third term.
10C8.
So it's just like what we did before.
Which is the second
Do you
one.
remember that if you multiply this all out, you're gonna have a 5x to the 10th in your first term, a 5x to the 9th in your second term, and so on, right?
Yes.
Well, we want the, what did I say, third term? We want the third term. So it's gonna have 5x to the 8th. Does that make sense to you? And if it has a 5x to the 8th,
The Y to the.
then it's gonna have a negative 3y to the second.
You're good.
Yes.
Now, what is that, what am I missing?
The coefficient.
The coefficient, you gotta have that coefficient. You can either build the triangle, remember, I'm gonna start it for you, I'm gonna build a few rows, but then if you want more than that, you're on your own, or you can remember that the coefficients to the 10th power will be 10C10, 10C9, and the third one is going to be 10C8.
Yep.
So my coefficient, or my number from the triangle, however you do it, is gonna be 45. So we have a 45, we have a 5x to the 8th, and a negative 3y to the second. So, I have no idea what 5 to the 8th is, it's big. So I got a 45, I got a 5 to the 8th, and I got a 9. 45, 5 to the 8th, 9. So that's going to be big.
Do you not have to do the 10C? Yeah, it's a big number.
I already did that.
No, for the other, like for the 3. You only do that for this.
There's one coefficient. Okay, so I got a big number, 158203125.
Yeah.
So 158,203,125. X to the 8th,
Y to the second.
y to the second.
Yep, that's what I got.
All right, and then one more for me, and then it's all to you. Okay, last one, number 5.
No, I know, but you like said the number and then she started.
Number 5 reviews a bunch of the concepts we talked about one day, but we really haven't spent much time with them since then. So here we go. We have 5 algebra books and 6 geometry books. Number 5. A. The books are all different. So it's just like on the shelf over there. I got a bunch of different kinds of algebra books, a bunch of different kinds of geometry books. How many ways can I arrange them?
30. No, guys. Dude, what are you talking about?
How many books are there? How many ways can I arrange 11 books in a shelf?
11 factorial.
11 factorial.
You got
The answer is 11 factorial. How many ways can I arrange them on the shelf? Now, listen, some of you said 30. If the question had been, how many ways can I pick one of each? That would be 30, because I have 5 choices of one kind and 6 choices of another. When we did those problems, I used my jumpers and shirts. It would be the same thing. So I multiply the choices, but that's not what's happening. I'm arranging them on the shelf. How many ways can you arrange 11 things? 11 factorial, period. I don't care if they're books, I don't care if they're people, doesn't matter, 11 factorial. Now, the books are all different, but they must be with their own subject. So what that means is, these guys have to stay together and these guys have to stay together. So think about that for a minute. Here are my algebra books. I'm gonna take the whole pile of them and put them on the shelf, because they gotta stay together.
5P6.
I'm really only arranging 2 things then. My algebra pile and my geometry pile. So I start with 2 factorial. But before I move here are my 5 algebra books. Before I gather them up and take them to the shelf, can't they be rearranged? How many ways can 5 things be arranged? 5 factorial. So, and the same with your geometry. So this is the answer to question B. This is the groups, we call them bundles. These are the bundles. And then these are each bundle.
Yeah, I know, I get it. As far as you understand the
The geometry books are all identical. So go back to the beginning, here are your books.
I gotta do a fraction.
There are 11 of them. This is like the repeated letters. There's 11 of them. But since every geometry book is the same, it's like having 6 G's in your word. So what do? Divide by 6 factorial. Remember, we divide by anything that's duplicates. So when we did that the most was when we had, remember Mississippi, we had those words?
Oh, the letters.
We had to divide by, we had a duplicate, we divided. This is duplicate books. Anything duplicate gets divided factorial. So this would be the answer to that. I mean, I don't know what that is, but that's what you guys did.
No,
That's what I got.
Wouldn't it be for C?
And then finally, this last one is kind of weird. So let's go back, we have our 5 algebra, we have our 6 geometry. Okay? The geometry books have to be kept together. Okay? Not the algebra. So I can, oh, there's an algebra book, there's an algebra book, here's my clump of geometries all sticking together. So how many things am I arranging big picture?
2.
5.
6. These books are not clumped. These are 3 individual books. Okay? That is clumped. So there are 6 things getting arranged to start with. But every clump, every bundle has to or can be rearranged. So that would be another 6 factorial. This 6 factorial is the 5 plus 1. This 6 factorial is the geometry books. They're just showing you the same number. Then I gotta turn around and divide by 6 factorial because why?
They're identical.
They're identical. Anything that's identical,
Has to be,
it's divided
By the
factorial. Yep.
Why is there never,
because it's only geometry. What happened if the colors are identical, or just be one way?
or 2 ways, 2 ways.
Oh, I like that. Because it could be like one on the left, one on the right, or it's not one here, one on the left, the other one. Okay. Well, we have a question like that, pretty.
Right? You might have a question like all these things, okay? All right, so when we get back from lunch, we will do whatever you want to do.
On the board, on the board.
On the board. Or not, I don't care. You think about questions you need for you. Tomorrow is D-Day, or hopefully A-Day.